All right, here we go. Let us get started on logarithmic properties, and we'll start with the very beginning, which is called the product property, and we'll explain that. First things first is, as you guys know, I almost got killed. I got punched, I got elbowed in the throat while playing basketball. Accidental, but almost died. So I might not be able to be as enthusiastic as I like to be, but I'm gonna try. Alright, so what I did first is we made this little table, and the logarithmic product property is, well, basically for logarithms, if we're look here, like log base, if we want to add logarithms, log base 2 plus log base 3, what would this equal? Well, if we look at our table, I kind of calculated log base 2 is 0.30 and log base 3 is log base 3 is 0.477. So if we were to just write the decimals, 0.301 plus 0.447, we get 0.778, just adding these using the calculator. Well, if you look at this table here, well, 0.778 is right there, which happens to be log of 6. So we know this is equal to log of 6. All right, well, let's try something else. I don't know. Let's try log of 2 plus log of 4. And what would that equal? Well, log of 2 is the same. It's 0.301. Log of 4, looking at my table over here, is 0.602. That's just from looking at this expression right there. And that is equal to, if you add these on your calculator, 6, 7, 8, 9, you get 0.903. Looking at the table, I'll write it over here. Plus, this is 0.903. Looking at the table, that's log of 8. So I know this is log of 8. Well, do you see any pattern, any connection here? Well, if you notice, well, what's 2 times 3? 2 times 3 is 6, right? 2 times 3 gives me the 6. Well, what about here? What's 2 times 4? 2 times 4, that's 8. That's giving me this expression here. So it turns out whenever we're adding logarithms that have the same base, we just multiply the inputs. Now you may ask yourself, well, what would be the base here? Well, it's an invisible 10. Well, we don't show it, it's an invisible 10. So let's go ahead and write our formula, and we're going to make sense of it. So the formula is this right here. Log base b of A, some input A, plus log base B has to be the same letters for the bases of C is equal to log base B of, well, you multiply the inputs, like the 2 and the 3. Well, in this case, it's just 2 letters, the A and the C, and you get AC, Mr. AC. And that is our formula. And we're going to experiment. Let's try it out. So what if I gave you log base 3 of 12x plus log base 3 of, I don't know, let's do 2x squared. How about this? Okay, well, if we look at this, first of all, we're going to combine these two logarithms into one single logarithm. It's going to have to be log base 3. The base stays the same. Well, because look at the formula. Well, this whole entire thing right here is like my A value. It's the whatever's inside the first log. And this whole thing right here is like my B value. It's what's in the second log. And we need to multiply these to get this third log. And so I'll kind of write it out. Maybe I'll use a different color. This is 12x, my friend. So let me write 12x times, well, this expression here, which is 2 times x squared. All right. Okay, going through. Well, what does that simplify to be? This is log base 3. Well, what's 12 times 2 is 24. And here we have an x squared, and x times x squared, that's just the same thing as x times x, which is x to the third. So 24x to the third. Wonderful. All right, let's go ahead and try maybe another one. What color would you like? All right, I think I read your mind. You wanted some purple. All right, let's try log of base 7 of 14y. All right, plus log base 7, and let's say y to the 5th power. What would that equal to be? Well, it's a plus sign, and we just know that means you multiply the input. So it's going to be log base 7. All right, of this first one here, so I'll write 14y times the second expression, the second log, which is y to the 5th. So this whole thing should simplify to be log base 7, and we're going to get 14, and there's no other number to multiply the 14. That's why it stays 14. And this is going to be, well, it's kind of like a 1 here. We have 1 y here and 5 y's multiplying. This is y to the 6th, or in other words, 1 plus 5 because this is a 6 on the exponent. Cool. All right, well, why not let's try just maybe one more challenging one that requires just a little bit more work. Let's try log base 4. And let's use, well, 2x to the 3rd power plus log base 4. And we're going to get, let's say 3, and then x to the 4th y squared. Kind of a challenge one here, right? Well, why don't we, before we begin, if we can, let's simplify these logs a bit. So we get log base 4. Okay, remember, there's like a 1 exponent here. We multiply these across. So 1 times 3 is 2, so we get 2 to the 3rd times x to the 3rd. We have to multiply the exponents. Okay, plus log base 4. All right, now when we go to do this one here, we do the same thing. All right, well, there's like a, I'll put a 1 there in front of the y for the exponent. And the 3's on the outside, which is why I kept the 3 on the outside. Well, 4 times 2 is 8, so x to the 8 times, and then 2 times 1 is y squared, and then we get y squared. All right, wonderful. So far what we have is log base 4 of 8, because 2 to the 3rd is 8, x to the 3rd power, plus, okay, we're going to get log base 4 of 3x to the 8 times y squared. Now that it's fully simplified, we can combine these to be log base 4. All right, I'm going to write the first expression, which is 8x to the 3rd here, 8x to the 3rd, times the second expression right here, which is going to be 3x to the 8 y squared. All right, my friends, here we're almost done. 8 times 3, what is 8 times 3? If I do believe so myself, that is 24. We have x to the 3rd, x to the 8th. Well, they both have bases of x. We just add 3 plus 8, 8, 9, 10, 11, 12, x to the 12. And there just happens to be this y, so times y squared. And that would be my final log. Hopefully you feel comfortable being able to use these log forms here and make sense of it. All right. Last but not least, if we're not convinced, I want us to try one last thing so that you can actually understand what we're talking about here. Let's do log base 2 of 4 plus log base 2 of 8. And this should equal log base 2. Well, 4 times 8 is 32, all right? And let me just show you why this works one more time, all right? This right here, we can solve this. This is asking us, this is saying 2 raised to what power is equal to 4, right? The 2 is your base, the 4 becomes your input, and so 2 raised to what power is 4? Well, think about it. 2 raised to what power is 4? That's 2 times 2 is 4, so that's 2 squared. So this log right here is just 2 plus, all right, this is saying 2 raised to what power is 8? Well, I'll do it over here. 2 times 2 is 4. Well, times 2 is 8. So this has got to be 3. Well, what's 2 plus 3? 2 plus 3 is 5. And we'll put it here, 5. Well, let's check to see, is this actually true? This is saying 2 raised to what power is 32? Well, if we take out our handy dandy calculator for a split second, we can actually verify that. And I don't know, if you want to just try, let's say you weren't sure, you just go 2 to the 4th, and nope, that's 16. So let's try the next one, 2 to the 5th. And what do we get, my friends? We get 32, which is exactly what we wanted. So this expression is 5. And that makes sense because we better get a 5 here. 2 plus 3 better equal 5. Just another way for you to see why these log properties work. All right, you have yourself a fantastic